Hi, I'm Al Karitz. I'm the Service and Applications Manager here at EMS. And I'm just going to give you an overview on my lab machine, how to set up for doing ramped carbon correctly, which will give you a very uniform thickness time after time after time. So first of all, we have the extended height bell jar, which is twice the height of your traditional bell jar, and it's installed by removing the shoulder screw, raising the arm up, and placing the screw back in the other hole. The stage height off the bottom is set so it's cuts across the face of the quartz crystal here. It's about 60 millimeters from there to there, and that's set and maintained. And the next thing we'll do is I'll show you how to program the ramped carbon protocol into the machine. Next we will discuss setting up the evaporation head and preparing the rods correctly. Lastly, we'll do the evaporation. All right. Here we are at our controller. I just powered the system up. If you look at the menu here, there is no process for ramped carbon. All the standard methods are there. So what we'll do is we'll create one. So we're going to hit Edit Profiles, New, and then you're going to pull down this menu and you're going to find ramped carbon. And it's alphabetized, so that should be relatively easy, one would think. There it is. It's not alphabetized, I take that back. Ramped carbon. So we're going to call this, and I'm just going to use abbreviations, RC for ramped carbon. 10 nanometers is what we're going to set it up for. Now you can set it up for any thickness you like, but we'll just do this for demo purposes at 10 nanometers. So you select OK, OK, and now ramped carbon appears at the bottom of the menu. You press OK, you get out of that particular setup, and now you have ramped carbon. So once again, we're going to go in and we're going to edit ramped carbon. And if you see his little plus sign here, it's got a sub-category, so we can look at that and make changes if necessary. It's not always necessary. So we'll hit Edit. So material is carbon because it's ramped carbon. This value you don't really change. Evaporation time, if you think that's gonna impede on it, you can tap it and make it to a maximum of 4 minutes. So that's what we'll do now, and make it 4 minutes. Outgas time you just leave alone. FTM controlled, tap this. Yes, you want it FTM controlled. Tooling factor you leave where it is. Terminate thickness 10 nanometers. If you're programming something else, you would tap this box and then you would change it between 1 nanometer and 2000 nanometers, okay? However, I must caution you, really thin coatings like 1 nanometer are not so easy to get reproducible. It's just beyond the scope of the machine. I would say typically 2 nanometers or 3 nanometers is probably as thin as you should probably go. So now we hit OK. Let's just look at the system values. Stage rotate, yes. Stage speed, blah, blah, blah. These are all preset. You don't have to worry about them. So that's how you program your controller for ramped carbon. Okay, so this is my setup for doing carbon rods. I've got one of these fancy trays that catches all the trimming dust and holds my shaping tool and a piece of sandpaper. So this is the 1.2 millimeter shaping tool. It comes in the accessory kit with the evaporator. If you have the blue handle installed, it just unscrews, pulls out. You just screw the red one in. It's not a big rocket science sort of deal to do. It has a collet which clamps the carbon rod so you can shape it. I use that nut there to set the distance, the total distance I want to shape the rod, because you need to prepare the rods before you can use them in the evaporator. Now, generally speaking, you shouldn't work with carbon rods longer than 60 millimeters in the evaporation head. So I have a little ruler here and come up with a 60 millimeter rod. The shorter halves can possibly be used in the evaporator, but on the stationary, not moving side. This is a final shaping tool which puts a bevel on the end of the carbon rod, which allows very precise evaporation. So step one is you sand the end of the rod flat. I mean, it doesn't have to be absolutely perfect, but a few swipes, it's pretty close. There's a little bit of angle to it, but we're not worried about that at all. The next thing you do is you insert it into the sharpening tool, push it all the way forward, tighten this down. Now the collet is pretty forgiving, but you can over tighten and snap the rod. I always leave my finger here at the end, and then I turn the sharpening tool away from me and I press gently. And this will take a little bit of time to get used to doing this without breaking the end of the rod. And I turn it until it bottoms out on the nut, which I preset at a particular length. Okay? So carbon evaporation is a very messy process. So we dump the debris in the tray, or sometimes if you don't have a fancy tray, you can do this in a little flat, sort of cardboard box, or a lid from a cardboard box. So that gives you a rod with a cylindrical 1.2 millimeter by approximately 4 or 5 millimeter long spigot, as it's known, or spigot. We only do this to one side of the rod. This rod now gets modified in this device. It's two-sided. It's one side is for 3 millimeter rods like we have here. The other side is for 6 millimeter rods. So we're going to use this side. So what you do is you gently lay it in the track there. You gently rotate and push it until it slides all the way in. You hold this in position and invert it and gently slide it back and forth until you're sliding just the metal. And what happens is you end up with a bevel on the end. Okay, so this is a perfect bevel. Now what we do is, like I said, sometimes we can use these other ends as the flat part. So again, what we'll do is we'll just flatten the end off, and it's good to go. So now let's move over to the evaporator head and place the carbon rods in the head and get it ready to go. Evaporation head, it's already installed inside the arm, and I find that this is the most convenient place to work with it. Now, periodically check this O-ring. As you can see, it does seem to collect quite a bit of carbon dust, and sometimes your machine won't pump, and It's not that these big gaskets have dirt or debris on it. It's usually this one. And then again, inspect this sealing surface and make sure that it's sealed. But like I was saying, the most convenient, comfortable place to work on this and load it is when it's already in the machine. So I just manually move the shutter out of the way, and yes, folks, I should honestly be wearing gloves, but I forgot to put them on at the beginning, so I'm just going to continue the way I am since this is just a test. You see some carbon debris build up. You just use your air blaster or any of the canned gases, and you can remove it. Also, if there's stubborn stuff, you can use a edge of an Allen key or a screwdriver just to keep all that debris off of there. So you can see that one side of the system is fixed position, and the other side is movable. I use these two screw heads as the center point of the operation. So that's sort of directly right over where your sample would be. So I carefully inspect the short rod, which goes in the fixed side, and I make sure that I've got the flat side forward, and I center it up just visually, and I tighten it down. Now these are just set screw, hex head screws. You can over tighten, so it will take a little bit of touchy-feely to sort of to gauge what level of tightness you really desire. You don't want it so the rod's slipping or moving, but you don't want it over tightened so you lose the piece of carbon and it moves, especially on the side with the sharpened and beveled spigot. So the first thing you do is you introduce the sharpened end carefully, because you can easily knock that tip off. Make sure that the screw is withdrawn. And I line it up so it's touching the other rod and the bevel is facing outward. So the next thing that you need to do is I have just a 5mm hex wrench. That's all you need probably from your toolkit. We make an offset of 5mm, and we just introduce that in between the fixed block and the movable part. We make sure that our rod is still lined up, and we tighten this. Okay, again, not to over tighten so we break the rod. The reason why we do this is we want this rod, as it evaporates, to feed and to continue to evaporate, because if you start the evaporation and the rods don't have a movable side and tension to drive them together, once the carbon in the initial ignition of the process happens, you're not going to, it's basically going to light up and it's going to go out, because the circuit that the carbon rod completes is open because it burned away. It's sort of like a fuse. So we have this spring-loaded drive system to keep the rod's tension at the right level. Now, I have found over the years, you just can't haphazardly set the tension. That's why I use a 5mm Allen key as a gauge. I set the tension exactly the same time, same strength, every single time, and this allows the reproducibility to happen. Another benefit of loading here in the head is it will accept those longer 60mm rods, because you can't remove the head or install the head with this much overhang on the end. Just personal observation. So Now it's ready to go. I'll just move that up, and we'll lower the upper and lower heads and lock them together. And now we'll hit Run Profile. So after pressing Run Profile, it'll first pump out the backing line to the turbo pump, and then you'll hear this click that you just heard, and that's the valve opening. And now you absolutely cannot open the lid by hand. Always make sure, if you walk away from the machine, that is indeed a seal on the vacuum chamber. So now it will go through its pumping process, and I have this system perhaps will be set up to do a pump hold, but we'll just let the video run. I may edit it shorter just for time's sake. This whole process should take about 5 minutes or so, depending on the time of the year. Humidity has a lot to do with it, whether or not you keep your carbon rods desiccated or not. Also cleanliness of your chamber. Mine's pretty dirty now because I've been using it pretty heavily. All these things factor into how fast the system will pump, and also how often you use it. I haven't used this in a few days. I've left it under vacuum to keep the chamber as clean and dry as possible, but still it takes some time to go through the outgassing process and into the extra pump time cycle, which is just letting the turbo pump spin fully up to speed and the vacuum to improve. I highly recommend that you take some time and wait for your vacuum to get into either it's going to say high vac here rather than an actual reading, or if you have the extended range gauge, it'll go down into the 10 to the minus 5. With carbon evaporation, the higher the vacuum, the higher the quality carbon foil that you create. So this extra pump time is just in there to allow that vacuum to improve, so you get better results. Okay, so now it's into a pump hold, and I have this turned on just because I'm really, strong believer of letting the system pump and remove as much of water vapor and atmosphere as possible for this process. So I'll set it, you can set it for a minimum of like 10 minutes all the way up to 24 hours, which is not needed, but if you want to, you can do that. So I'm just going to continue on because this is just a demonstration. We're not after the real deal here. So all you do is you hit continue, and now we'll go into the ramped carbon process. So first of all, it's outgassing. It tells you that here it outgasses for a certain length of time. The carbon rod is glowing ever so slightly, and then it does pre-evap ramp, and as you can see here in the chamber, that it gets to a point where it's actually evaporating. This current keeps on going up very slowly, so this is a very controlled system, and you can see the thicknesses. This is the thickness of carbon on the FTM. This is the rate at which it's coming down. So this is not a rapid blasted on type carbon process that you would for just hitting your carbon rods with full power and just just blowing tons of carbon off of them. This is a very precise, slow method, so you can get very good reproducibility and very good quality thin films. If you just want carbon down for a coating for EDS, pulse carbon rod is perfectly okay. You don't really care how much carbon you get down, you just want a conductive sample. But if you're making carbon foils that you may want to float off or use as a support substrate on a grid, you really want to use this very slow method. It's a little tough to see what's going on in the chamber because this is where I cleaned it and it's pointing to the wall and you can't really see. But the rotary stage is spinning around, the substrate is getting carbon on it. You can see we're up almost to 50 amps. We've produced 9 nanometers per minute carbon coating rate. We're up to 8 nanometers. We're going for 10. So far, the total elapsed time since I pressed the run process is 6 minutes 46 seconds. Okay, so it completed its 10 nanometers of carbon. It closed the shutter, shut the evaporator off. It's stopping the turbo pump, and it will next go to the vent cycle. Vented now. Let's look at the evaporation rod. It looks like, you know, you haven't used very much, and you really haven't. And you can go and use these same rods again, but you can't. Remove them, knock the spigot off, flatten the ends again, sharpen the rod, just repeat the process. Otherwise, you're not going to be able to get reproducibility. Also, what I usually do is I have a little lab timer here, and I start the timer going because it's good to allow this carbon evaporation head at least 10 minutes in the air to cool down, because it's quite hot, as you can see. I dropped that like the proverbial hot potato. So you want to let this cool down a bit in between. Yes, it's meant for high temperature, but the polymer insulator will only handle a certain amount of heat. The O-rings that are in there will only handle typically 80 centigrade temperatures, and then they may fail and cause a vacuum leak. So we let it chill for a little while. The optimal thing that you can do if you want faster turnaround, because while this is pumping to do one carbon process, you can purchase a spare carbon insert and not use the longer 60 millimeter rods, but use a little bit shorter ones. And this way you can have one head prepared. Once the evaporation process is done and the system's vented, you can quickly remove this, put the next one in, and speed up the process. But you would have to purchase another insert. So there you have it. That's what it takes to produce carbon foils that are pretty uniform across the board. Let's put it on this piece of paper. So that's about 10 nanometers of carbon. So that ends this demonstration.